Hey there, Algebra 2 students. I hope that you are well. Today we need to talk about the sum and difference formulas for our trig functions, sine, cosine, and tangent. These are formulas that we will use to find exact values of certain functions. So it's a little confusing, but we'll refer back to these formulas again and again. So keep them handy. Okay, so for example, let's start with the sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. We're going to use that formula to find the exact value for the sine of negative 75 degrees. Now, I don't know how to find the sine of negative 75 degrees off the top of my head, right? There isn't a nice value for 75 degrees on my unit circle, right? Negative 75, I don't see it. I see a 330, which would be a negative 30 degrees. 315, which would be negative 45 degrees. Wait a second. Negative 30 plus negative 45. That equals negative 75. So let's use that. Right? Negative 30 degrees plus negative 45 degrees is equal to negative 75. And so negative 30 will be my A, negative 45 will be my B. And so the first thing that I do is I just substitute those values in for A and B in that formula. So I'll have sine of negative 30 times the cosine of negative 45 degrees plus the cosine of negative 30 degrees times the sine of negative 45 degrees. And let's see, well, what is the sine of negative 30 degrees? The sine of negative 30 degrees. Remember, sine is the y value on our unit circle. So negative 30 corresponds with 330 degrees. And so that would be negative 1/2. So sine of negative 30 is negative 1/2. Cosine of negative 45. Cosine is the x value. And negative 45 corresponds with 315 degrees. And so that's the square root of 2 over 2. Right? The cosine of negative 30 degrees. Cosine is the square root of 3 over 2. And the sine of negative 45 degrees is negative square root of 2 over 2. Okay, so we have found the sines and cosines of those angles, and now we need to multiply and then add together. So when we multiply 1/2 times the square root of 2 over 2, we get the square root of 2 over 4, and it's negative because that's a negative 1/2. We also have the square root of 3 times negative square root of 2, and that becomes a negative square root of 6 over 4, and then we want to combine those two to make a single fraction, and so it would be negative square root of 2 minus the square root of 6 all over 4. Okay, that is one example. We'll do one more with radians. Let's see here. Can I get my camera to hold still? Okay. This one looked a little tricky, so I was like, oh yeah, let's do that one. Cosine of 35 pi over 12. That's a lot more than 2 pi, right? So that's more than one revolution. So 35 pi over 12 minus the 24 pi over 12, which is your 2 pi, leaves you with 11 pi over 12. Okay. 11 pi over 12 is an angle that is equal to 35 pi over 12. So can we break up 11 twelfths into some fractions that can be simplified that might be on our unit circle? Here it might be tempting to go with 5 pi over 6 and then 6 pi over 6. That's doable. Nope, nope. Those are sixths, not twelfths. Sorry, my brain is not working right now. So sometimes you have to try different things and check and see if they would work. My favorite way to break this up is 3 pi over 12 and 8 pi over 12. 3 pi over 12 simplifies to pi over 4, right? And 8 pi over 12 simplifies to 2 pi over 3. And because this is a cosine, we're going to use the cosine of a sum, which is cosine of A times cosine of B minus cosine of A minus the sine of A times the sine of B. So my A will be the pi over 4. My B will be 2 pi over 3. And then we start plugging them in, right? Cosine of pi over 4 times cosine of 2 pi over 3 minus sine of pi over 4 times the sine of 2 pi over 3. And the cosine of pi over 4, if I forgot, I can look on my unit circle. It's the square root of 2 over 2. Square root of 2 over 2. And the cosine of 2 pi over 3 is up here, negative 1/2. Minus the sine of pi over 4, which is pi over 2, square root of 2 over 2. And the sine of 2 pi over 3. Sine of 2 pi over 3 is the square root of 3 over 2. Okay, so the square root of 2 over 2 minus times negative 1/2 minus the square root of 2 over 2 times the square root of 3 over 2. And then when we multiply these together, we get something that looks very familiar. It's negative square root of 2 over 4 minus the square root of 6 over 4, which is negative square root of 2 minus the square root of 6 all over 4. These are just a couple examples to help you get used to using the sum and difference identities, and I hope this helps. Let me know what questions you have. We'll see you next time.